Have you ever wondered why sound works so well underwater? Sound actually travel much faster in the water than in air, about 4 times faster. That's because water particles are packed closer together, allowing vibration to move more efficiently. In the ocean, sound speed changes with temperature and pressure. Warmer water and greater depth help sounds travel faster, bending sound wave and creating special paths like the Sova channel where sound can travel huge distance. That's why sound is the ocean's best way to communicate and explore.
Shadow zone. Why sound disappear in the ocean? As we go deeper in the ocean, sound speed tends to change. They move faster in warm water, while in the colder water they are slower. We look at the physical wave propagation and refraction. The speed of sound in the seawater depends on temperature, pressure, and salinity. This creates multiples of layers in the ocean with different sound speed. When sound moves between layers in the ocean with different temperature, which creates different sound speed, it refracts according to the Snell law for waves. This refraction causes sound waves to curve, producing shadow zone and convergence zone. So we come to our proposed solution. First is the distributed acoustic buoys. They deploy at multiple depths to avoid the shadow zone. They act as relays between surface ships and deep sea units. Second is the adaptive signal processing, a real-time adjustment of frequency and transmission angle, an echo cancellation algorithm to reduce multipath distortion. Just think as when you're trying to change a signal in your radio to find the right channel.
Let's move on to the third issue, which is how to reduce multipath interference. First, you must know what is multipath interference. Multipath interference is when wave such as signal or radio wave travel from source to a transmitter via numerous paths. This happens because when signal reflect from the surface and bottom of the sea. First technique to reduce multipath interference is called beamforming. Beamforming is a signal processing technique that narrow the transmitter signal. In short, the normal receiver signal is white shape, but with this technique, it's a straight line, so it can reach a further distance. And the second technique is called time gating. In a simple word, time gating is more like a filter signal. This is because we can adjust the transmitter to only receive signal during a specific time duration.
Most marine life relies on sound for communication and echolocation, especially whales and dolphins, which uses sound as domain sense in range around 10 Hz to 150 kHz. If our sonar overlap with this frequency or other specific value, it will cause acoustic interference that might disrupt vital behavior and at high intensities can cause physical injury and death. To avoid such accident, we use a sonar that operates outside sensitive biological frequency range. Since most large whales here based in lower frequency, we use frequency above 100 kHz, which is ultrasonic wave, to bypass the sensitive range. Next, we use adaptive power control to minimum power of sonar to reach the receiver, so we can minimize physical harm to marine life, also prevent blasting the entire ocean with unnecessary noise. Lastly, we use soft start technique by gradually increases sound intensity instead of transmitting at full power instantly to allow marine life to move away from the radius of sensitive frequency. Also maintain communication effectiveness at the same time reducing ecological impact that might harm marine life.